Sequential Batch Reactor, SBR. Tonight we're going to talk about biological treatment as it once started. Hello, Magnus Holberg behind the microphone. So let's take a look at SBRs. Now, something about the SBR and conventional activated sludge. First of all, classical SBR started in the late 19th century, started the biological treatment. Then the conventional activated sludge, or CAS, took over after the SBR. Why that happened, I will tell you in this video also. And also a development in the late 20th century with a continuous inflow SBR, or the ICEAS. Right hand side, I put up an article. From that article, I picked the information for this video and presentation for you. Why did it start with the SBR and how is it different from the conventional activated sludge process? First of all, with an SBR system, you can do equalization of the sewage coming in, primary clarification, most cases, biological treatment, and also secondary clarification in a single reactor or a tank. Furthermore, with the SBR, there is operating and flexibility and control built in the SBR system. Smaller footprint because you can do everything in one tank. Also, cost savings in regards to eliminating, for instance, the secondary clarifier and other equipment. How does the classical SBR works? First phase, when you fill up the tank with sewage. You come to a certain level, you stop. You go into the second phase, which is aeration and, reaction and the biological treatment. Then, after the aeration, you go to the third phase, settle or sedimentation. You let the sludge settle. When it's settled, you go to the fourth phase, the draw phase, where you empty the treated water out. Then you come to the idle phase, where you wait for new sewage to come into the tank. Also during the idle phase, you pump out the excess sludge or waste sludge. Now let's compare the SBR to the conventional activated sludge system. Here you see the conventional activated sludge system. You have the primary clarifier where you remove some BOD, some phosphorus and nitrogen from mostly particulate material. Then you come into the aeration stage. After the aeration, you have the secondary clarifier where you separate the treated water from the sludge. Also, you have the return activated sludge stream going back to the aeration. How do you compare this to an SBR? First of all, with a classical SBR, you don't need a secondary clarifier. You don't need a pump to back the return activated sludge. Also, in most cases, you can remove the primary clarifier from the SBR. Not in all cases, but in many cases. In the end, you have one tank left instead of two tanks and a pipe going back, pumping back activated sludge or return activated sludge. Why was the CAS system favored over the SBR system when it started with biological treatment? It was difficult to control the distribution to the SBR tanks. The reason for that you can see here, because when you filled one tank up, you need to have a second one to take the sewage coming in. Depending on flow variations over the day, it could be difficult to control the tanks. Furthermore, related to this is in the early days, there were no PLC and less sophisticated monitoring equipment. Today, the CAS system giving PLC control system, I would say control-wise, it's not an issue anymore. In the late 20th century, there was development of the SBR into the intermittent continuous extended aeration system, or short ICEAS. The ICEAS system has a continuous inflow, which means that during the aeration phase or reaction phase, you have an inflow to the tank. You go to the second phase, the sedimentation phase. You still have an inflow to the tank, and to a third phase where you decant, you still have an inflow to the tank, And also during decant phase, you waste the sludge or pump out the excess sludge. So by having a continuous inflow, you decreases the 5 phases down to 3. Furthermore, you don't have to worry about having a tank ready to take the inflow when you shut down one tank to do the reaction. Comparison between the classical SBR and the ICEAS system is that with the classical SBR you need minimum 2 tanks, but with the ICEAS system you only need 1 tank. And of course the ICEAS is more easy to operate. That ends the information about SBR, the CAS and the ICEAS system. For the last slide I have 2 pictures again, but these are not from Gotland but from Stockholm and the new metro. And I thought you got a little bit bored about Gotland maybe. I don't know how many watch my videos, but I thought I should change a little bit from Gotland to Stockholm, where I've also lived quite a long time. 2 nice pictures from Stockholm Metro. So with this, I say as always, thank you and remember, water really rocks. Take good care. Bye bye.